In order to understand the behavior of TCP, especially on the receiver side, we must simulate it in Omnet++. For that, in this module, we shall explore what is the support given in INET, how exactly does it get implemented, and what functions do we use specifically for evaluating the performance of the receive buffer. RFC 1122 identifies the host implementation requirements. In those, it is specified that a receive buffer is to be implemented at the receiver that takes segments from the sender, buffers them till they are processed and passed on to the application layer. The inherent support given in INET to implement the receive buffer in TCP, it does not consider segment by segment transmission as the only way to recall and manage the packets. Instead, it counts every byte. As you already know, that TCP is a byte stream protocol. There are few implementations, however, which are the variants the support is given in Castalia and Vane, in which the segments are also stored on the basis of segment ID. However, for majority of the cases, the sequence numbers of each byte are used to keep a track of the buffer occupancy on the receiver side. Let's look at the figure that we have seen earlier, in which the receiver keeps track of the available buffer by knowing exactly which was the last byte sent and which was the last byte acknowledged. Without going into much detail, all we can recall is that using the sequence numbers of the last byte sent and the last byte acknowledged, current occupancy of the buffer can be analyzed. As you can see, the sequence number which is closer to the application is the one which has been processed and acknowledged, and the farthest or the most away from the application is the one which has just been received. Now, if you look at the INET support for receive buffer management, we can actually look at the TCP receive queue. It contains a function called get amount of buffered byte. This gives the number of buffered bytes currently buffered in the queue. This may include the out of order segments or the sequence numbers belonging to the out of order delivery as well. Another function called get amount of free bytes. It returns the number of bytes which are currently available. Using these two functions, we can exactly determine the performance of the receive buffer. The reference class is shown in here. What we are currently using to determine the receive buffer performance is TCP byte stream receive queue and TCP message based receive queue. So as I said earlier, both the byte count and the segment count can be used to determine the performance of the receive buffer.